Here's a prime example of actually a really easy reflection question that's made difficult by the fact that you haven't been given the reflection line or the line of symmetry drawn for you. So the first thing we need to do is interpret the question. It says to reflect shape A, which is this one, across the line y equals minus x. Now, a lot of people would panic at this. All you need to remember is, whatever y is, x is going to be the same as it, but minus. So, for instance, if you have minus 1, then the y is going to be the positive of it. Oh, I should draw the points. So, for instance, if y was 2, then x is going to be the negative of it. And these two would meet here. Now, if y is 3, then x would be negative 3, and they would meet here. And you notice, if you plot a few points, eventually you end up with a straight line. And because you cannot have a negative of 0 or positive of 0, it's just 0, it will go through the origin. So now what we can do is draw that line on. I always suggest it's best to plot 3 points on any line you draw. 2 to give you the direction of the line, and the third point to check it's definitely the line you want, because if you end up with a point out here, you know you've got an error because all of your 3 points should sit on that line. So now we need to reflect the shape across this diagonal line. Now, the only 2 diagonal lines that they tend to give you are either y equals x, where your points would be 1 and 1, 2 and 2, 3 and 3, 4 and 4, 5 and 5, or y equals minus x, which faces this way, whereas y equals x would face this way because it's a positive gradient. Okay, so going back to what I said before, draw some perpendicular lines on. Use your ruler and use them accurately. So I'm going to draw a perpendicular line to match this point, and I'm going to do another one to match this point, and I'm going to do another one to match this point, and one more to match this point. So now I know that this point is going to run along here, and this point is going to run along here, and so we carry on. Now what we need to do is actually work out where they sit. So you can either measure them and then measure exactly the same length over here and put on a point, or you can count squares. Now, if you're counting squares, you need to do both your horizontal and your vertical change. So I'm going to show you how to do this now, and I'm going to draw it on for you. Let's just set up a line segment and change its colour in a second. So, ready? We're going to go 1, 2, 3, 4, 5, 6 this way. So that means because it's being reflected, it's going to go 1, 2, 3, 4, 5, 6 this way, and then we're going to, oh, I can't count, oh no, that is right, okay, and then I'm going to go, no, sorry, I haven't got my glasses on, and that needs to come back one, sorry, as does, whoops, oh dear, silly me, okay, sorry, just take this a step back. What I did there is I didn't quite line this up with the correct point. If I'm working along this line, I need to have my point in the right place. So I've travelled 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5. So that means I have to go 1, 2, 3, 4, 5 this way, and then 1, 2, 3, 4, 5. So 1 point sits there. Now, if I had counted wrong, my point wouldn't have ended up sitting on this line correctly, and it would have sat perhaps on one of the other lines or not on a line at all, so I know that's wrong then. So actually drawing your perpendicular lines on really helps you to see whether you're doing it right or not. Okay, so let's try the measurement method now. So let's measure the distance between this and this, which is 7.07, So now I'm going to create a line with exactly that same length from here, so 7.07, and when I move this, it should snap onto the grid nicely, which it does, just there. Now notice that because my points are snapped nicely to the grid here, and because I'm reflecting across a diagonal that has a 1-to-1 gradient, meaning that your number that's used here is the same as your number used here, that they should, this side, snap onto the same line as well. And then here, so I've used that line and that's fixed. Now let's try doing this one with the counting technique. So I went 1, 2, 3, 4, 5 up, down, so that means I've got to go 5 up, and then I am 9 away this way from the centre of enlargement. So I'm going to go 9 this way, and then I'm going to go up. Have I done that right? Hang on, check. 9 to 0, yep. 1, so from here I'm going to go 9 this way, 9, and then 1. Oh, I'm such a muppet, sorry I didn't invert it. So I've got to go 5 this way because I'd gone 1, 2, 3, 4, 5 that way, and I need to go 9 this way. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it should sit here. Notice that because I put the grids on, I realised straight away that I'd gone wrong. Okay, so now, oh, come on, you want to sit there? There we go. Okay, and then the last one is, where is it? 3 down and 1, 2, 3, 4, 5 across. So I want to go 3 up, sorry, 5 across, 5 up and 3 across. Honestly, these are my marbles. So basically all you're doing is you're inverting the way that you've travelled. So for instance here, look, I went in the X direction, I went along 5 and down 3, so the inverse of that would be to go across 3 and up 5. So they're basically the reciprocal of each other. So now what I can do is match these up, and I'm just going to zoom out a sec to help myself so that I make sure I match them up in the right way. So I'm going to join up all the points. I've got that one to that one, to that one, to that one, and that one, and then that one. So this shape here is the reflection of that, and just leave your lines on, okay, as long as you make your points really strong, and perhaps shade the shape if you really want to, just so that the examiner can see it clearly. Remember that your exam paper is going to be scanned, so you need to make sure your points are really, really strong. Leave your construction lines on, it just makes it nicer. And that's it, that's how to reflect a shape.